Hey guys, welcome to the third episode of the 6-Week Project. In this episode, we're going to be talking about the CAD process and every step that our team must take to develop one fully functional robot on the computer before we finally design it in real life. I hope you get a lot out of this video and maybe some ideas for your own team. Enjoy!
We're currently working on building the lift mechanism for our robot. We are planning on only going up to the first rung of the pyramid and climbing up to get 10 points.
We designed a disc pickup system.
Hi, I'm Jonathan. You might remember me from the last episode. I'm working on the Frisbee feeder system to get the Frisbee from the floor into our shooter. And our basic design right now is basically a long system of belts where the belts pick the Frisbee up off the floor, move it through the bottom of the robot, and then push it up into a vertical where it goes straight up and then flops right over into our bucket where it will then be shot out into the three-point goal. So our basic design has rollers at the bottom that bring the Frisbee up off the floor and onto this roller ramp that brings the Frisbee to the back of the robot. And then we're gonna have some sort of pneumatic piston or something that pushes the Frisbee up into a vertical position. And then after it does that, the Frisbee will climb up the vertical section all the way to the top where the belt on the inside will be a little bit shorter so that when the Frisbee reaches the top, it'll flop over and into our bucket where it will then be shot out of the shooter.
Next, we designed a shooter.
I'm Connor Blomquist, and I'm the shooter design lead. Okay, so our shooter features two wheels that have the standard modular gearboxes. The back wheel is geared so it's slightly slower but has more power to give the Frisbee the impart the initial inertia. And then this one's geared so it's a little bit faster but has less power. And then there's these channels in the front of the robot, or in the front of the shooter, that are perfectly the size to let the Frisbee fly out of it. And then there's eventually going to be a 5-gallon bucket here because we figured out that that's the exact perfect dimensions to have Frisbee in. And then attached to the 5-gallon bucket, there's going to be like a mailbox slot that goes to the feeder station. And then to kick the Frisbees into the shooter, there's just a really simple pneumatic actuator here that has a triangle attached to it. And as the triangle extends, it has a right angle attached to it, and it forces the Frisbee forward and into the shooter. And then the whole shooter assembly is mounted to the robot frame with this A-frame.
We designed a drive base in CAD.
Originally, our team planned on using the stock Andy Mark drive base, but we decided against it because the distance between this brace and this brace is 11 inches, which is also how wide a Frisbee is. To replace the stock Andy Mark drive base, we started to construct this frame, but with 2 sim motors on each gearbox, but then decided against it because the dimensions were wrong. We realized halfway through this wouldn't work with the bumper rolls. Okay, this is our third and hopefully final design for the drive base. There's a wide gap between the 2 braces so that a Frisbee can fit up through it, and it fits the rules, correct rules this time. It's going to feature 2 sim motors on each gearbox, and hopefully this will be the last time we have to redo it.
Thanks for watching. Join us next week when we start to finally build our robot.